In my previous video, I left a big question unanswered: why I purchased the expensive Ubiquiti UniFi Protect Viewport instead of just DIY some much cheaper, smaller computers to do the exact same thing, right? So in this video, we are going to address that question. I'm going to compare the performance among the 5 devices to do the exact same thing, streaming the exact same layout from my lab environment from the UniFi Protect cameras. I'm going to show you the Apple TV result, 2 Raspberry Pi versions, 3 and 4, and then a very old MiniPC. Let me justify why, in my opinion, the UniFi Viewport maybe is a better choice. Of course, you can purchase a new, very power efficient and very powerful new Mac or MiniPC to do the same thing, right? But remember, this video is about what if you do not want to spend any money. Just use whatever you already have as alternative to stream the live video. You may know Ubiquiti does support RTSP. You can stream the video using other software. So this video is only about Ubiquiti's native functionality. I'm going to have another video focusing on Ubiquiti's RTSP setup and how to utilize it in external softwares, for example, Synology, ZoneMinder, or even Apple TV. These are the 5 devices we are going to test in today's video: the UniFi Protect Viewport, a 4K Apple TV, a very old Raspberry Pi 3, and a relatively new but already outdated Raspberry Pi 4, and a Intel NUC MiniPC. First, the result of the UniFi Viewport. As you can see, the display is in 4K and the layout is for 2K cameras. You can see I'm moving a LED light from left to right, right to left. The changes on the 4 streamed videos, they are very smooth. There's no any delay. What you see now is after I SSH into the UniFi Viewport. As you can see, this is the real-time result for the Linux top command. The 8-core CPUs are pretty idle, and you can see a whole bunch of Android system services are running. They are busy working on the buffer compositing and graphic rendering, so the device is taking the seemingly heavy task effortlessly. You can see now it only consumes 4.2 watt, very power efficient. In fact, Apple TV would have been the perfect streaming device for UniFi Protect because it has very good hardware. It supports 4K, it has built-in power supply, and it's relatively power efficient. But why we need a dedicated UniFi Viewport? Because Ubiquiti has limited the feature on the Apple TV app for UniFi Protect on purpose. It's almost unusable. I will show you. Ubiquiti does have an app for UniFi Protect on Apple TV. Originally, when I saw this app, I was very excited because I thought that's exactly what I need. But after launching it, I was astonished. You can see the screen layout is fixed in grid fashion. Whatever layout you define in UniFi Protect Web UI, the app simply doesn't take it. You can see the UNVR-1 title. It takes such a valuable space on purpose. There's no way to hide it. If you click any camera, it will automatically play it in full screen. You cannot see other cameras anymore. Thanks to the great hardware of Apple TV, as you can see, the app can stream the 4 cameras videos effortlessly, and if I move the LED light, all the videos can change immediately. And when you are only streaming videos from one camera, in the right side you can see the familiar UniFi Protect history control, so you can use your remote, scroll down and up to smoothly scroll through all the histories. So the experience for the app is good and bad. Good because every operation which it does support is very smooth. The bad part is it's deliberately limited. When it comes to power consumption, so when I use the Apple TV to stream 4K cameras on a 4K display, this is the power consumption, 14.5 watt. Not as efficient as the UniFi Viewport, but not too bad. I don't own a Google Chromecast, but as I know, it also has a similar app as in Apple TV. In the past, it did support full screen, very space-friendly layout, but it seems recently that feature was removed, and now the app is in the same situation as the counterpart in Apple TV, which is you cannot define the grid layout. A lot of the screen space will be wasted. But if I'm wrong, let me know in the comments. The last thing about Apple TV, I do know on Apple TV App Store, you can download some third-party CCTV apps. I'm going to discuss that in my next video about RTSP. If the Raspberry Pi 3 can be used for my use case, I will be super happy because it's almost useless due to the very weak hardware and it's accumulating dust for years already. Yes, it's pretty power efficient, but you need a external power supply for it. No big deal. But whether it can take on the task I want, let's see. On the Raspberry Pi 3, I have installed a fresh Raspberry Pi OS, the 32-bit legacy version, which is based on Debian. The hardware only supports 1K display. I have launched the default browser, visited the UNVR site. So far, no problem. If I go to the live view, I switch to the testing layout. You can see the 4 live views, they are struggling. You can tell from the static screen and the 3 dots flashing, which means the system is trying very hard to buffer data, but it just cannot catch up. After a while, the upper left and lower right are seemingly stabilized. I can see the screen changing every second, even though apparently the video quality is low, but at least I can see 2 of the 4, right? If I move a LED light from left to right, you can see 2 of the 4 views. They can reflect the light change smoothly in low quality. The other 2 screens, they are simply showing nothing at this moment. This is the current resource utilizations. As you can see, both CPU and memory, they are not 100% utilized, which means the bottleneck is not really on CPU or on memory. This is the power consumption for the Raspberry Pi 3. You can see it's only 4.67 watt, even a little bit higher than UniFi Viewport. Viewport is streaming in 4K. But still, it's a shame that it cannot even support the 1K live view. Otherwise, it's a perfect choice. If the Raspberry Pi 4 can work, I will be very happy as well. I really like the hardware. It has USB-C power input, and there is a huge advantage if this one can be used for my use case, because I have some very cheap PoE splitter purchased from Amazon. So you plug in the PoE here. It has a non-PoE Ethernet output plus a USB-C power supply. So you don't really need this small power brick. You can directly use this very elegant connection, just like what you can do with the UniFi Viewport, right? It's not very old, in fact. So you will see I'm super surprised that the result is very embarrassing for this Raspberry Pi 4. I installed the Ubuntu on the Raspberry Pi 4. By the way, I also tried the 64-bit Raspberry Pi OS. I have the exact same result. So the operating system is not really a factor in the bad result. You can see by default, the resolution is 4K. Let me launch the default browser, Firefox. You know what? I already have bad feeling because no matter I do what, the mouse cursor movement and the screen refresh, they are all super slow. Go to live view. Okay, so you can see the 3 dots on each view. So it's super slow, it's buffering, it's struggling. Let me switch to the full screen. After several minutes wait, there's no response at all. I cannot even move my mouse cursor, so the system simply doesn't respond to anything. I have to reboot the Raspberry Pi. So maybe it's simply due to 4K display. It's too much for this small computer. So let me try to switch to 1K. Let's see whether it will change anything. Okay, resolution has been changed to 1K. Let me launch the activity monitor so that we can see whether CPU usage is very high. Relaunch web browser. Okay, go to live view. Yeah, this time the response is much better, even though the system is still struggling on buffering the views. Switch to full screen, no problem. Give it some time. Let's see whether any video will be stabilized. So you can see the CPU utilization is almost 100%, which means that's the bottleneck. Sometimes some videos will get the buffer done, but just stay for 1 or 2 seconds and then it continue to struggle. Toggling between the low quality and high quality video, it doesn't really help a lot. So now there are 2 videos, the top left and bottom right. They are stabilized. Let me try to move some LED light to see whether they can smoothly reflect the change. Yeah, you can see it's not smooth at all. It's struggling. Sometimes it will reflect the video, sometimes it simply doesn't. Very bad testing result, even worse than Raspberry Pi 3. About the power consumption, when it's struggling with 1K, you can see it's a little bit more than 7 watt. You may wonder whether it's because I use the PoE splitter and it cannot provide enough power. I tried to exclude the factor by using the default power brick. It didn't help. You may also wonder the CPU utilization is 100%, whether it's due to thermal throttling. Yes, I tried to exclude that factor as well. In fact, I have been using a tool to blow winds to the CPU directly. It didn't help. This is a very old Intel NUC MiniPC. Originally, it has Windows 10 Home installed. Just to be fair, for today's testing, I installed Debian 12 on it. Of course, you need to use an external power supply. I thought, okay, at least it's a PC, right? It should work perfectly for my simple task. But you will see the result. You can see the default screen resolution is 4K. Let me launch browser, Firefox. Okay, it's very responsive. Go to live view. Let me show the activity monitor so that we can see whether CPU utilization is high. Okay, change to the test view. Make sure it's high quality. Go to full screen. Even the operations are very responsive, the system is still struggling with buffering. You can see so far only 2, sometimes 3, sometimes 1 videos are buffered, but it's not very stable. Let me give it some time. In the meantime, you can see the CPU utilization is already 100%. Almost same situation as the Raspberry Pi 4 when it's in 1K, even though it's slightly better. Let me give it some time. You can see if I switch to low quality, it doesn't really help about the buffering. Now let me try to change the resolution to 1K. Changed. Go back to browser. Okay, this time is much better. It immediately started smoothly streaming the 4 videos and the CPU utilization is not high at all. Keep in mind this is 1K. Then let me use the LED light. Yeah, no problem. All the 4 videos are streaming smoothly. Let's check the power consumption for the MiniPC when it streams in 1K. It's about 15 watt, higher than all the other devices we tested today. Okay, finally all the testings are done. Let me summarize. For the UniFi Protect Viewport, it can effortlessly support the 4K streaming and it consumes pretty little power. For Apple TV, it's very smooth. It has some features which UniFi Viewport doesn't have, but the bad thing is the functionality is restricted on purpose so that it's not really good choice if you simply want to check the live view of your UniFi cameras. And for the Raspberry Pi 3, it only supports 1K and it's not usable, it's too weak. For Raspberry Pi 4, in 4K mode, it simply doesn't work. In 1K mode, it's struggling. And for the old Intel MiniPC, it only works perfectly in 1K mode. If we switch to 4K, it's too weak to support it. So at least for all the 5 devices I tested today, the UniFi Viewport is the only device can support the major purpose for my use case. And the Apple TV can be used in some scenarios. The old MiniPC can be used if you are okay with 1K display. One minor thing of using computer as the live view device is you need some kind of way to interact with the operating system. So you either use local mouse or keyboard, which will make your setup very messy, or you use remote desktop. But remember, the computer hardware we are talking about here is very weak already. So running a additional remote desktop software will only make the situation even worse. Okay, thanks for watching.